Hey guys, so we're going to start out second semester with section 8.1. I'm so sorry I'm not here, but this is a pretty easy lesson. People usually do really well on the quiz that we have from 8.1 to 8.3, so I think this will go fine. So our learning targets today are that I can write an equation to model direct variation. I can write an equation to model inverse variation. I can determine if a table shows direct or inverse variation, and I can model real-world situations using direct and inverse variation. So the first thing we're going to do is talk about direct variation. And direct variation is an equation that can be written in the form y equals ax. So when you see y equals ax, or when you see direct variation, y equals ax is what we should be focusing on. And we say that that's when y varies directly with x. In a direct variation, if you think about slope-intercept form, the slope is going to be a, and the y-intercept will be 0, 0, because you can see that there's no visible v value. So the first type of problem says, write and graph a direct variation equation that has the given point as a solution. So when it says direct variation, that means that it follows y equals a times x. Well, it gives us an x and a y. So let's put -9 in for y and -3 in for x. And let's solve for this a value. Dividing both sides by -3, we get that a equals 3. So the direct variation equation, again, is in this form, y equals ax. So our final answer is what happens when we put that 3 in for a. Y equals 3x. That's our direct variation equation. And we know that that's going to have a slope of 0, or just kidding, a y-intercept of 0, and a slope of 3. So we can move up 3 over 1 to the right, down 3 over 1 to the left. And that's what our direct variation equation looks like. Again, it'll pass through the origin if it's a direct variation equation. Okay? So we can do the same type of a thing in letter B. Again, direct variation means we're going to follow y equals a times x. And this time we're going to put -2 in for y and 6 in for x. So we will divide by 6 and we get -2 6, which is like -1/3. Again, this is not a direct variation equation. We need to put this value in for a for it to be a direct variation equation. So that means that y equals -1/3 x will be our direct variation equation. So again, to graph it, we have a y-intercept of 0, 0. And we can move down 3, just kidding, down 1 to the right 3, or up 1 to the left 3 to find our slope, connect the points, arrows on the end, and again, that's what our direct variation equation will look like. Okay? So this is one way that we can find a direct variation equation. If we know it varies directly, then we just substitute the values in for x and y. Example 2 is similar. Again, it says that the variables x and y vary directly. So varying directly means we're going to have this y equals a times x idea. It wants us to write an equation that relates x and y if x equals 11 when y equals -44. So this is really the first thing that we need to do. So let's find a. So in for y, we can put the -44, and in for x, we can put the 11, and then this allows us to find a. Dividing by 11, we find that a is -4. So we notice that then our direct variation equation would be y equals negative 4x. So that's one of our answers. So notice the first thing we did is we found A. The second thing we did is write our direct variation equation. Well, now notice there's a second part to this. The second part wants us to find y when x equals negative 8. Well, all that means that we do is we'll use this direct variation equation, y equals negative 4x, but we'll put negative 8 in place of the x. So if we substitute negative 8 for our x, that means that we get that y is 32. So we did the two things. We wrote an equation relating x and y, and we found y when x equals negative 8. Okay? As we saw in example 1, your constant of variation, which is a, and that's what a is called, your constant of variation, can be any sort of number. It doesn't have to be an integer. It can be a rational number also. So why don't you guys try the U-try, okay? So I will pause the video, and maybe you guys can pause the video and you guys can give this one a try. Okay, did you notice something a little different about the U-try? It started out the same. We used y equals ax since it said very directly, and we substituted the given values in to find that a was negative 0.8, and our equation will be y equals negative 0.8x. But this time notice that it asked you to find x when y equals 2. So we still use the equation, except this time we substitute 2 in for our y in order to find our x, which will be negative 2.5. So make sure you're very conscientious about which variable they're asking about. All right? So let's look at how we can do this in a real world situation. In example 3, Hooke's law states that the distance d that a spring stretches varies directly with the force F that is applied to it. Let's not even go any further than that. The distance a spring stretches varies directly with the force. That means that the d is like our y, so we're going to say d equals varies directly. The varies directly means that we have our constant of variation a multiplied by this force here. So the distance varying directly with the force means that we're going to use d equals a times f. So now let's use that. Letter A. Suppose a spring stretches 15 inches when a force of 9 pounds is applied. So if the spring stretches 15 inches, that's the distance. So d is 15. The force of 9 pounds is telling us that F equals 9. And now we have an example X and Y, in this case F and D, to put into the equation to find our A value. So again, we're using the idea that D equals A times F. In for D, we can put 15. In for F, we can put 9. And this can help us find our A value. Dividing, we get 15/9, but we see that that can reduce to 5/3. Now, A equals 5/3 doesn't relate D to F. We need to put that 5/3 into the equation, and now we have a direct variation equation relating D to F. Similar to what we did above, this is asking us to predict the distance that the spring will stretch when a force of 6 pounds is applied. So again, this is just telling us to let F equal 6. So we're going to use this D equals 5/3 F, but in place of F, we're going to put 6. And so that means that D is going to be 30/3 or 10. And it looks like the distance was measured in inches. so I will say that my distance is going to be 10 inches that it is stretched. Okay. So one thing that we want to do is be able to tell if a table shows direct variation. And one important thing to know is that we see direct variation if your y, oh, can you see this? Sorry. If your y over x is constant. And I'll even put relatively constant, to be honest with you. As long as it's pretty close. If you're using real world things, sometimes it's not like exact. But notice that we had this equation, y equals ax. If you divide both sides by x to isolate the a, notice that that's supposed to be your constant. Your a is your constant. And so in that case, if you divide y by x, and that is constant, then that shows that it's direct variation. So this says the dimensions of 5 rectangles, each with an area of 24 square feet, are given in the chart. Tell whether the length and width show direct variation. If so, let's write an equation that relates the quantities. So if we want to see if it is direct variation, what we're going to do is we're going to check y over x and see if we get the same answer all the time. So let's try to divide y by x. So 24 over 1 is 24. 12 over 2 is 6. 8 over 3 is 2 2/3. It's pretty obvious that this is not the same. This is not constant. And if it's not constant, then that means that there's no constant of variation for direct variation. So that means that this is not direct variation. Okay. So we tried to test this, and it turns out that there is not a constant when we divide y by x. So we cannot model this using direct variation, and therefore can't write an equation. Okay? So we've been talking a lot about direct variation. Let's talk about the inverse variation, okay? So remember, two variables x and y show direct variation if y equals a times x. So another type of variation is called inverse variation. And inverse variation is going to be the case if they're related like this. Y equals a divided by x, as long as your a is in 0. Notice that you can also write this as x times y equals a. Notice if you multiplied both sides of the equation by x, then that gives you that x times y equals a. And again, the constant a is called that constant of variation, but this time, if it's related in this fashion, it's said to y is said to vary inversely with x. So that's the thing. Direct variation is going to be y equals a times x. Inverse variation is y equals a divided by x. So let's look to see if these different equations that are given in example 5, if these show direct variation, inverse variation, or neither. Well, let's look at letter A. xy equals 1 over 22. We'll notice that this is in the form x times y equals a. Notice we said that was a way that inverse variation could be written. And so this is going to be an example of inverse variation. In letter B, a lot of people are like, oh, there's division, it's inverse variation. But remember, inverse variation is when we have y equals a divided by x. This doesn't have a equals, or y equals. So let's try to isolate y and see what happens. Let's multiply both sides by x and I see that y equals negative 3x. Well, notice that this has the form y equals a times x. And which equation did that represent? That represented direct variation. Look at C. C just is a hot mess. So again, what we could do is we could try to isolate y and see what happens. So we'll cross multiply. I get negative 1y equals 2x. I can divide by negative 1, and I get y equals negative 2x. Which one do you think this fits? Well, notice that it has the form y equals a times x. And which one was that? That's right, it was direct variation. What about letter D? All right, let's see. So if we isolate y, I could subtract x. So I get negative y equals negative x plus 2. I can divide, I get y equals x minus 2 if I isolate y. Notice that it doesn't have the form y equals a times x because there's an extra constant. It doesn't have the form y equals a divided by x. So this is neither direct nor inverse variation. Okay? So here are two problems. Why don't you guys try and decide if this example, these examples are either direct, inverse variation, or neither. Okay? I'll let you guys pause and try that. Okay, let's see how you did. In the first one, notice that this is in the form x times y equals a, or you could isolate y by dividing by x, and it's in that form y equals a divided by x. Notice that both of those are ways to write inverse variation. Now, in letter B, a lot of times people divide and they're like, oh, there's a fraction, it's inverse. But I want you to think about what that means if you have negative x over 12. Isn't negative x over 12 the same as negative 1/12 x? That means that that's the form y equals a times x, so that's direct variation. So you really have to think about where your constant is, and actually if y is isolated, where x is. If y is isolated and you're multiplying by x, it's direct. If y is isolated and you're dividing by x, it's inverse. Notice here we were dividing but not by x, so it's direct. Okay? So now let's write some equations using this inverse variation. Here this says that the variables x and y vary inversely. And so what that means is that you're going to use this idea that y equals a over x. Or you could use x times y equals a. Doesn't matter. You'll get the same answers, okay? So first, let's use the values to write an equation relating x and y. So in this problem, we see that y is 8 and that x is negative 2. So I'm just going to put that in to that inverse variation equation. Now to solve for a, what I would do is I would multiply both sides by negative 2, and I get that a is negative 16. Again, the equation that we write is going to involve x and y. So the inverse variation equation is going to be y equals negative 16 over x. Okay? Now, again, it says find y when x is 4. So let's use this equation, y equals negative 16 over x, but now let's put 4 in for x. So negative 16 over 4 is negative 4. So y is negative 4, basically when x is 4, okay? So those are the two parts to example 6a. Let's try the same thing in example 6b. So again, this is varying inversely. So we know that y equals a divided by x. So in for y, I can put negative 24. And in for x, I can put 1/2. Now that seems a little strange to be dividing by 1/2. Remember that dividing by 1/2 is the same as multiplying by 2. So this is really the same as -24 equals 2a. So if you keep it this way, you can either multiply by 1/2, or if you think about this way, you can divide by 2. Either way, we get that a is -12. So therefore, our equation is going to be y equals -12 over x. There's your equation. Now we want to find out what happens when x is 4. So that means that we'll take -12 over 4, and we find that y is going to be -3. And so that's what we can do for inverse variation. So it's just like what we did on the front with the direct, except we use a different base equation because it varies not directly, but inversely. So take a second and see if you guys can try these next two U-try problems. I'll pause. Okay. So here's what I ended up with. In letter A, I just set this up since it was varied inversely as 7 equals a over 3. Multiply by 3 to get a is 21. So the inverse variation equation is y equals 21 over x. Putting 2 in for x, there's not much I can do, so I just said y is 21 over 2. If you put 10.5 or 10.5, that's fine. Now in letter B, we have y equals a over x again, because it varies inversely. So we have 12 equals a divided by -3/4. So again, dividing by -3/4 is the same as multiplying by -4/3. So that means that in order to isolate a, I had to multiply by -3/4. And you can see that here. If we were dividing by -3/4, you'd multiply by -3/4 to get that a equals -9. You also can always think about this as, if you don't like dealing with the fractions, remember another way that you can find a is just a equals x times y. I mean, that's what we're doing essentially, right? We're just multiplying the x and y together. So you can do that to find a in these problems if you want. And then the inverse variation equation would be y equals -9 divided by x. Putting 2 in for x, we get y equals -9 over 2. Okay? All right. So that's a little bit about inverse variation. Okay. So remember, we said that the general equation y equals a over x for inverse variation can be written as x times y equals a. So that tells us that any set of data points, x, y, shows inverse variation if the products x, y are constant. So in example 7, we're giving you tables, and you want to decide if x and y show direct variation, inverse variation, or neither, okay? So here's what I can tell you about that. I left some space up here for you. If you have direct variation, remember that your a is going to be y over x. That's what your a would be. So what you're going to do is you're going to test to see if y divided by x is constant. Okay? So we talked about that on the very front, that's what direct means. Okay? Now, what then would inverse look like? Well, remember that inverse variation, we said, was a equals x times y. So what that means, if it's inversed, you're going to test to see if x times y is constant instead. And if x times y is constant, then that tells you that it's inverse variation. Okay? So let's try that in example 7. We have these different x and y values. So the first thing I'll test is if it's direct. So let me see what y divided by x is. And you could use your calculators for this if you wanted. I don't know if you can see mine up here. So if I took 5 divided by 1.5, that gives me about 3 1/3. I'll just put 3.3 repeating. if I took 3 divided by 2.5, oh, that gives me 1.2. I mean, I could test another one. 1.875 divided by 4 is 0.4685, so 0.47. Are these constant? No, okay? Since these are not constant, that means that it's not direct variation. Okay? So if it's not direct variation, now we have something else to try. Now let's test x times y and see if we can get something constant. So let's take 1.5 times 5. That gives me 7.5. 2.5 times 3 gives me 7.5. 4 times 1.875, 7.5. 6 times 1.25. Are you guys seeing a pattern? And this one's pretty obvious. Notice that they're constant. Okay? So because it was constant, because x times y was constant, that means that it's going to be inverse variation. So we've decided it's inverse variation. But now it wants us to write an equation relating the variables. Well, we know that inverse variation equations are y equals a over x. But what the heck is a? Any ideas? Remember, a is your constant of variation. Wasn't this 7.5 the constant? So what we'll do is we'll put that constant that we got in for our constant of variation, and we're all set. And so that's how we can deal with the tables. Let's try the same thing in letter B. We have new sets of x's and y's, and so what we can do is just start by testing to see if it's direct by y divided by x. So if we take 20 divided by 20 divided by 4 is 5. 12.5 divided by 2.5 is 5. 17.5 divided by 3.5 is 5. I know negative 10 divided by negative 2 is 5. 21 divided by 4.2 is 5. Notice that this is constant. So since y over x is constant, that means that it's direct variation. So we've made that decision. And we know direct variation is y equals a times x. And what is our a? That's right, this constant that we found here, 5. So that would be our equation, y equals 5x. All right. Now some of my favorite problems are problems like example 8, where they're going to tell you that things vary directly and or inversely with different things, and you write an equation with that. Okay. Remember that when you see direct variation, it's basically your constant a times the variable. And when you see inverse variation, you're going to see your constant a divided by the variable. And when you're writing these equations, you're writing an arbitrary equation. So I'm just going to write a little note. Don't forget a in your equation. That's what I often see on quizzes and stuff. People will forget the a value. So we don't know what a is, but we're going to put it into this random arbitrary equation. Okay? So 8a says Q varies directly with R and inversely with S. So Q varies means we're going to have Q equals. Directly with R means that we're going to have A times R. And inversely with S means that we would be dividing by S. And that's all you do for those. That's why I like those. Okay. All right, let's try letter B. B varies inversely with the square of C. So B varies means we're going to have B equals. Inversely with means we're going to have A divided by something. And this says the square of C. Not the square root, but the square. So that means C squared. And again, that's about it. Okay? All right. See if you guys can do these. Let's pause. Okay, how'd you do? W varies, so W equals, directly with the square root of y, a times root y, and inversely with z, over z. There's your equation. Letter B, H varies directly with the cube of j, and inversely with the square of k. These didn't say roots over here. They said the cube and the square. So the cube of j is j cubed. The square of k is k squared. So H varies directly with the cube of j, a times j cubed. Inversely with the square of k, divide by k squared. And that's it. All right, I'll let you guys get started on the homework. Hopefully you have some time to start that. And hopefully I will see you guys soon. Thank you. Have a good day. Oh, check your answers on my classes.